Hi folks, welcome back to Physics with Captain Rod. So making this one to help you out with number 16 in your homework. And this is about Timmy on a rocket ship here. And there's some weights given, 90 pounds and 60,000 pounds. So, and a rocket thrust given in newtons. The first thing you probably need to do here is look up the conversion factor between pounds and newtons. It is approximately, I believe, 5.2 newtons equals 1 pound. Please look that up and verify that. Should be right around there. Maybe it's 5.15 or something like that. But you're going to want to look that up and then convert both of these to newtons. Okay, now, let's see. Part A, find the acceleration of the rocket. So start by drawing a free body of the rocket. And although it wasn't explicitly mentioned here, I guess, but I'm pretty sure this means, like, here's the ground. This thing has just taken off. So you're going to have a fairly significant gravitational force and this force upward. And then write a Newton's second law equation. Now the rocket is accelerating in theory here. It's looking like this way. So when you write your force equation, sum of all forces equals ma. All right, remember Captain Rod's rules of thumb here, carrots. Identify the acceleration direction, call that positive. This rocket is accelerating hopefully that way. So you should be able to write a force equation there and then find the acceleration of the rocket. Next, let's see, find Timmy's apparent weight while the rocket engine is on. So, when you stand on a bathroom scale, right, the scale itself does not actually measure your weight. Okay, let's say here's our scale, and here's Timmy, or a person standing on it. What the scale measures is the normal force between your feet and the scale, right? Some quick, simple evidence of that. If you took the scale, put it against the wall, and pushed on it, it'll read a value. It'll read the normal force between your hand and the wall. Now, when you're standing there in the bathroom, you're not accelerating, right? So a free body of the person, hopefully it's reasonably obvious if you draw a free body and you write a force equation with the person not accelerating, the normal minus the weight would equal 0, and the normal and the weight are the same. But if Timmy's on the rocket and the rocket is accelerating, right, then the right-hand side isn't equal, all right? So what you want to do here for part B is draw a free body of Timmy. So free body of Timmy, and then write a force equation, sum of all forces equals ma, with a positive. Keep in mind this 90 pounds. When you do a conversion to newtons, that's not the m in the ma. Once you know how many newtons Timmy is, that needs to be converted to kilograms for the right-hand side of this equation. So hopefully that'll get you through part B. Part C, let's see, find the maximum height reached by the rocket if the rocket runs out of fuel for 20 seconds. So this is just a review of the chapter 1 stuff. So once you find the acceleration, and that's good for 20 seconds, right, sketch a velocity graph. And I will get this started for you. Assuming the rocket started at time 0, velocity 0. And then I'd probably do this, write this out. Acceleration is equal to change in v over change in t, and you have an acceleration from, I think, part A, known value. Here's a delta t, known value. Now you can calculate a delta t, or I'm sorry, delta v, which means on our graph, 20 seconds, and you should get some number out of this, right? And then we'll make our standard constant assumption, or constant acceleration assumption. Now, I don't want to give the rest of this away, but once the rocket runs out of fuel, the rocket then will start dropping in speed. It becomes basically a free fall situation. And think about, what does the rest of this graph look like? I'll also mention this. So when the rocket gets to its highest point, imagine what is its velocity at the highest point. That should give you a pretty good clue as to what this looks like. And then when it says find the maximum height, right? That's a displacement, and hopefully we remember by now what property of that graph, I guess, is going to tell us that. So hopefully that'll get you through that problem. Contact me if not. Hope all is well, and have a great day.